Okay, these problems are all about distance equals rate times time. And here is a typical one. A boy took off in a balloon going 20 miles an hour and landed 1.2 hours later. His dad left on a bike 24 minutes after the balloon took off from the same location. He caught up with the balloon right as it landed. What was the dad's average speed while riding the bike? These can be like really hard to do if you just have to figure it all out by yourself. But if you're able to use a system that I'm going to show you, they're going to be a piece of cake. All right, first of all, I'm going to hand out problems so that you don't have to be squinting up at the board to read them, and you can do your work right on here. So I'm going to hit pause for just a second on the video. Okay, back ready to go here. So here is what a problem like this is based on. Did you notice that they're talking about distances and rates and times? Therefore, it's based on distance equals rate times time. So we're going to make a little chart. And you're going to do this on each problem. D equals R times T. And you want to kind of spread it out a little bit because you're going to have to fill in for each person what was their distance, what was their rate, and what was their time. Now we have the boy and we have his dad. So we write boy and we have dad. Okay, now the distance. Starting it right off with a tough one. It doesn't tell me the distance that the boy went. Okay, it says he went for 20 miles an hour, and it tells me his rate, and it tells me his amount of time he spent, but it doesn't tell me his distance. What do you think I should put if it doesn't tell me that? A variable, and what's a logical variable to put for distance? D. And then it does tell me the rate, 20 miles per hour, and it does tell me the time. Now don't put units in there like hours or miles per hour. We just keep it pure. Just make sure that if you use miles in one spot, you use miles in the other spot. Or if you use hours in one place in the chart, you better use hours in the whole chart. Because if you use minutes some places and hours in other places, get all messed up. All right, so the time, 1.2 hours is fine. If you wanted to change that to minutes, you could. But then you're doing a problem that has miles per hour on one part and minutes on another part, and that's going to get you messed up. You want to use the same rates the whole time. All right, so far, are you with me? Now the distance for the dad. Think about this. If I use D again, I'm saying that the boy and the dad went the same distance. Is that true? Yes. Yes, it is, so I can put a D there. If they had gone different distances, I would not be able to use a D again unless I said like D plus 1 or something. But if I say they're exactly the same, then by saying D and D, I'm saying that their distances were the same, and they were. And he went 24 minutes after the balloon took off, and I don't know the rate. What should I put if I don't know the rate? R. And the time is 20. If you put 24 minutes, that is so wrong. I can't even explain how wrong that is. Because not only, it's not how long he was going, it's how many minutes later he was going. So if you think of it this way, I don't know if you know this, 24 minutes can be changed into hours by dividing by 60, and you get a decimal, and what is it? What? 0.4. So we should right away change this to 0.4 hours. That way we're using one person. If we use 1.2 hours for the one person, we got to do this other one in hours. And even putting 0.4 here would be totally wrong. Dad did not go for 0.4 hours. He waited 0.4 hours, and then he took off. So we should take the son's time, which was 1.2 hours. And how long did Dad go? 1.2 hours minus the 0.4. He didn't go. The dad didn't go longer amount of time. He went less amount of time because he waited 24 minutes and then he took off. Okay, so bottom line is it's 1.2 minus 0.4, or instead of that you could have put 0.8. See how that took a little bit of calculating? Not a lot, but a little bit. And now the problem is going to be very easy to solve once you've set these up, because now what you've got is two equations. This first one I'm going to make in green. D equals 20 times 1.2. The next one I'm going to make in black. D equals R times 0.8. So how do you solve them? You use substitution. And it says D equals R times 0.8. I'm going to put R times 0.8 right there, because D is that. So I can put R times 0.8 or 0.8R right there. Just wait. Then I can solve for R. And is there another way you could do it? Yes, there's another way you could do it. Either way, you're going to have to solve for R. So I'm going to put 0.8R right there, and it'll be 0.8R equals 20 times 0.12, which I don't know what that is. Would somebody help me out with that? What's 20 times 1.2? 24. Okay, so then 0.8R equals 24, and I'm almost done. Now I divide by 0.8 on both sides. R equals 30. All right. And does that make sense in the context of the problem? And we were doing miles and hours, so does it seem reasonable that Dad was going at 30 miles an hour if his son was going at 20 miles an hour? Yeah, that seems reasonable. Now, it's kind of fast for a bike, but it's possible. It'd be riding really hard to get that going that fast. But maybe he's going downhill, good point. Maybe he's just really motivated because he's scared that maybe his son he's afraid he's going to get hurt in the balloon or something, so he's riding really fast. Anyway. Okay. Moral of the story is, set up a little box like this. This little red box. Distance equals rate times time. And then the tricky parts will be in here. Figuring out what to do when in the distances are the same, it's pretty easy. Sometimes you have to calculate a little number to put it in the box. But once you get the box filled out, it's just two equations, and it's easy after that. All right, let's do another one together. That is the whole answer, but I already did it with you. Here's the ball being hit between two outfielders. Yes, this little graphic that's kind of annoying after a while. It just drives you crazy.
Spin around, upside down.
No, it's not. And yes, I have a little YouTube clip of, this is a situation where people are in the outfield and boom! Sometimes that kind of thing happens. Anyway, so a ball was hit between two outfielders who are 110 feet apart. The first thing I would do is just a little picture, not a detailed drawing, but just a little picture. I've got a ball being hit between two outfielders. Okay, so there's an outfielder over here and an outfielder over here, and the ball's hit between them, like somewhere in there. They're 110 feet apart. So that's 110. The center fielder ran at the ball going at constant speed. So let's say this is the center fielder and this over here, and he's running at the ball and he's going at 8 feet per second. And the right fielder ran at the ball going 5.5. So they're going to hit each other. Now, if I tried to do this just from the picture, I would fail terribly. So I'm going to make one of those charts. Okay, so next let's make a D equals R times T. We'll make a little chart. We have two people, two fielders, and we got the center fielder and we got the right fielder. Always important to label them so you don't get confused. Now, one of the best approaches is to go through and fill in what we know. Like, do we know the distance that the center fielder ran? No. Do we know, so we should put a D. Do we know the rate? Yep, the center fielder was going how fast? 8. Do we know the time that he was running for? No, so we put a T. The second line is always harder because you have to think a little harder. The right fielder. Do we know what distance the right fielder ran? No. But if I put a D in here, that's what a lot of kids do. They get it wrong because you're saying that the center fielder and the right fielder will cover the same amount of distance, and we don't know that. So I cannot do D, and I cannot change the variable to something else, but how can I use a D and something else? No, I'm not talking about a different variable here. I'm talking about using D and then, yes, what you're thinking. Exactly. Here's why. 110 is the total distance minus D. D is the distance that the center fielder went. See, the right fielder is going to have to go whatever distance that the center fielder didn't go. So you take the total of 110 and you subtract D. Here's another way to say it that works for some kids if they don't get what I just said there. Would you agree that if we add up the center fielder and the right fielder, that it should add up to 110? Add the two things that I circled in green. Don't those add up to 110? Because see, the positive D will cancel the negative D, and then the answer will be 110. So that's how you do it. All right. And moving on, the rate of the right fielder. They give me that. It's 5.5. So I write a 5.5 here. I guess it should be consistent in red. And lastly, the time that the right fielder ran. Now think about this for a second. Exactly. If the ball was hit and they both start running for it, right? Shouldn't the time that they spent running be the same as each other? And so this is one where you think it through, and time is equal to time. These are the same amount of time, so you put just a plain T there. Remember, when you're saying that, you're saying that the center fielder and the right fielder must have ran the same amount of time. Now that you got the chart filled out, rest is easy. So tell me the first equation, please. Yep. And the second equation, 110 minus D equals 5.5T. And then I just use substitution. I could either I got D is 8T. That's the easy thing to stick in. Wherever I see a D, I should stick in 8T. So I could put it right there. And so then this is 110 minus 8T equals 5.5T. And then I subtract, let's see, I got T's on both sides. I'm going to subtract 110 next. You could have done it a different way. Actually, I probably should have. But. And then I'm going to divide, or no, subtract. No, what am I going to do? I could subtract 5.5, or I could add 8T. I know it's going to be weird. There is probably a smarter way to do this, but this is going to work. I'm following all the rules. 0 equals 13.5T minus 110. Now I'm going to add 110 to both sides. See, that was dumb. Because I minus 110 from both sides. Now I'm going to add 110 to both sides. That was it took an extra step because of me being dumb. But that's all right. We all are dumb at times. As long as that's nice. 13.5T. And then I divide both sides by 13.5. And then I'll have my answer. Somebody must have a fast finger with the calculator. I'm going to go to 8.15. Is that on the right? Does that sound logical now? Because the other kid was going at, let's see, if we're trying to find the time, 8.15 is time. That's like 8 seconds. Ball gets hit. Now, these are little kids. Okay, we're not talking about pros, because I know it would probably be way less than 8 seconds before they would hit. But if they're little kids, I can buy 8 seconds. That seems reasonable. Okay, how do we do it again? We started with the distance equals rate times time. We stuck in all our numbers. Once we figure out those numbers, it's easy from there. All right, next one. Plane leaves Minneapolis, traveling 430. Now, you'll notice the first problem we did, the people were kind of chasing each other like this. The plane left, or the balloon left, and then Dad chased him the same direction. The next one was where they were going opposite directions like this. They were going right towards each other. What do you think's happening now? Going away from each other. So this situation goes like this. One plane goes this way from Minneapolis heading that way, and the other plane heads from Minneapolis going the exact opposite direction. All right. So I'm just making a quick sketch here of my situation. Now I'm going to do my D equals R times T. Please always do it this way. Excuse me. If you have another way you want to do it, that's fine, but you need to do at least 3 problems my way so you learn how to do this. And after that, if you want to do it other ways, as long as you show your work, it's fine. But see, other ways sometimes will work for one kind of problem. My way works for all these kinds of problems. And some kids were like, making lists and stuff, and that works, but it won't always work. Sometimes it'll work for certain kinds, but not for other kinds. All right, anyway, this will always work. Minneapolis plane, I got plane 1, and I got plane 2. It doesn't really matter what I call them, but I got 2 planes. The distance that they go. Plane leaves Minneapolis traveling 430. Okay, I know its rate's 430. It doesn't tell me how far it went, so I gotta put D. Does it tell me how long it went for? Well, kind of. But it only says that it was, compared to the other plane, it's going for 1 hour longer than the other plane. So it doesn't really tell me, so I put a T. Yep. Plane 2, and now remember, these are easy. If you don't know them, you just put a letter. But the second line, that's harder because you got to think. All right, what do we know about the distance? Even though we don't know what each plane was separately, we know the total distance. So you do 1,500 minus D. Yep. That way when you add them together, the total will be 1,500. The rate of this plane, thankfully they tell me that, 480. And then the time. I don't know how long it was, but if I put T in there, I'll be saying that they went the same amount of time, and they didn't. You got it, T minus 1. Because he went 1 hour later, so he traveled in the plane for 1 hour less. All right. Now that you got the box filled out, it'll be a piece of cake. You got 2 equations, and you know what? Let's not even solve it right now, because it'll take you a bunch of time that I want to focus on setting up the equations. Because once you got the equations, you've been doing this since algebra 2 years ago. The only thing I might remind you about is that T minus 1 would be in parentheses. So if you just said 480T and then minus 1, that'd be wrong. It's got to be 480 times the T and 480 times the negative 1. Got to distribute that out. Okay, let's move on to the next kind of problem. Oh, by the way, if in case you already were really fast and you wanted to figure it out, that's how it would start. Oh wait, I don't have the answer for that one. I thought I did. Okay, I think it ends up being 2 hours and 10 minutes, if anybody went to the time to figure it out. 2.18 hours or something like that. Anyway, train leaves Philadelphia at 1 p.m. It's traveling at 65 miles per hour towards Denver. Another train leaves Denver at 4 p.m. and it's traveling at 60 miles an hour towards Philadelphia. The distance between the two cities is 1725, and the trains are on the same track. When will they crash? So basically, one's going this way, one's going this way. It's just like that baseball problem again. Okay? And I'm going to set up my D equals RT. Except this time, I think you have all the tools you need to do this one. So I'm going to give you a second and see if you can do this correctly. Remember, if you don't know one, just put the letter. But on the second train, for the Denver train, you'll have to be more careful than just slapping in a letter if you don't know. Okay, I need to get rolling here so that I can get finished before lunch. The Philly train, the distance, I don't know, but D. I know the rate, 65. The time, does it tell me how long I traveled? No, it doesn't. Time. See, the first one's easy. Then the next row is the one we got to think. I know that the distance between Denver and Philadelphia is 1725. I can't just put 1725 there. 1725 minus D. Raise your hand if you did that part right. Good. And the next part, rate. I know that. 60. And then the time. I can't just put T because that would imply that it was the same amount of time. But one left at 1 and the other one left at 4. 3 hours difference, so t minus 3. Very good. If anybody put the t plus 3 on the top, that actually would end up having the same effect. But it's better to do it consistently, and I bet most of you did the minus 3. Raise your hand if you did the minus 3 down there. Good. And then you just have to multiply them out, solve the system of equations, and it's easy from there. One last thought on that. If you have this, d equals 65t, and 1725 minus d equals 60 times t minus 3, you could use your calculator to do this for you on today's homework. If you think about this, you'd have to be consistent about how you write the letters. Remember how we always did x first, and then y, and then we put the answer over here in our matrix? Well, in this case, it's d and t, and then the answer. Know what I'm talking about? So, if I wanted to do it that way, I'm just going to show for those that are interested. The d, I could just put, what number's in front of that d? 1d. And then I'd have to move this to the other side, and that would make it, what? Negative 65. And what would be left that it is equal to? 0. Good. And then the next one, if I want to get d alone here, I'd have to put the 1725 to the other side, and then multiply by negative 1 to get, oh boy, that would get pretty ugly. Actually, I could just subtract 1725, put it over here, almost, and then I have negative 1 here, and then this would be how many t's? I have positive 60 t's. And the last thing would be this times this, and then add it to that, and then put it here. So bottom line, if you want to use that, you can. Okay, lunchtime.